Okay, hello everybody, back to another video. Sorry we haven't been uploading for a while, it's just, sorry about that, I don't really have an excuse. But today what we're going to be doing is all about parabolas, but not just all about them, we're going to be reflecting them over a horizontal line. So my friend asked me this question, so I decided to just answer it, I guess. So, yeah, if we try to graph this, our x and y axis, we've got, well, a horizontal line would be y equals k. Or, sorry, I wrote that backwards, but yeah. So, essentially, if we try to graph or try to write down our actual standard form of a parabola, it would be that. 4p times y minus k equals x minus h squared. So, basically what it means is the center of that thing is hk. And this equation is called the point-slope-intercept form of a parabola. So it's really useful because the P over there tells you the distance from the vertex to the directrix or the focus. And another thing it really tells you is the lattice rectum. The lattice rectum's length is what I'm showing here. That is the lattice rectum. And how you find that is it's just 4p. So using that information, if we clip that, where the top equation is the parabola, and then the bottom equation is the line. As such, I'm trying to draw arrows right now. Yeah. So if we clip that, try and clipping it to the next page. Yeah, I'll just drag it down really quickly. Yeah, it won't let me. Oh well, it's fine, that's close enough. So if we actually try to graph this equation, well, first we should actually, before trying to graph it, we should put down some important details. So 5, 7, and that's the vertex because, well, you could tell from our standard form of the equation. So if we graph this, the vertex is 5, 7, that's a point, I'm sorry, and the page broke so I couldn't really draw well, but whatever, that's the parabola, and that's the line y equals 7. So the really cool thing about this specific line is that the vertex lies on it. And we could be able to use that, but for now let's just solve it normally. Y equals a times x minus 5 squared plus 7. And how do we know that? Well, because the vertex doesn't change. So the new form of the parabola, it would still be something of the form x minus 5 squared plus 7. So all we need to find is a. And how we do that is to just find a point on the normal parabola and then just reflect it over line y equals 7. So trying to do some mental math here. We've got 4, that's 3 times negative 1 squared plus 7, which is 10. So we've got 4, 10. And if we try to graph that, wait, my thing isn't working, there we go. Yeah, so there's the x and y axis, 4, 10, and the line y equals 7. There's the line y equals 7. So, yeah, that's the y-axis, that's the x-axis, and we would just flip it over the line. So that much distance from a point to a line would be 3. You don't need any fancy formulas for that. It's just perpendicular, so yeah. So yeah, 4, 10, that would be 3 above y equals 7. So the next one would be 3 below y equals 7. So that would be 4, 4. So now all you do is plug it in and solve for a. And then we have our parabola. So let's just do that really quickly. 4 equals a times negative 1 squared plus 7. So we've got negative 3 equals a. And there we go, that's it. So now, we could have told this, like we could have already knew this from the beginning. Let's just write down our answer first. Y equals negative 3 times x minus 5 squared plus 7. So yeah, how we could have known this, that's our answer. How we could have known this is because the vertex lies on the line y equals 7, which means the entire parabola would just be phasing downwards. That's just negating the squared term. So, yeah, how you would do that is just attach a negative in front of the 3, and then the entire parabola would just go negative. So, yeah, that's how you would do it really quickly. I kind of knew that in the middle, which is why I kind of stuttered in there. But, yeah. Hopefully that helps. My friend asked me this, so to my friend who asked me this, If it helps, cool. If it doesn't help, I'll make another video on it. And yeah, that's pretty much the entire work. That's like the algebraic move. But yeah, the logical move would be the y equals 7 lies, the vertex lies on the line y equals 7, so all you do is have to negate it. But whatever. Hopefully you all enjoyed, and bye!